So our next topic in coordinate proofs is going to be looking at coordinate proofs but with rectangles and rhombi, rhombi just being the plural of rhombus. So a basic definition that we will stick with for a rectangle is a quadrilateral with 4 right angles. And this is good to keep in mind whenever you're doing a proof, whether it be a 2-column or a coordinate proof. If you can prove or need to prove something is a rectangle, it's always easy to think about the definition. I want to prove it has 4 right angles. So here below we have quadrilateral EFGH, and it's asking us to calculate the slopes of all 4 sides. And then we need to use those slopes to prove that it's a rectangle. So looking at side EF, if we plug it into the slope formula, we're going to have 8 minus 2, and then 3 minus a negative 6. So if we subtract on top, we get 6. Our denominator is going to be 9, and we always want to reduce our slopes to simplest form. So I have a slope for EF of 2/3. Now, if we do the slope of HG, they should be parallel since they're opposite each other. And if we plug that into the slope formula, our numerator is -4 minus 2. The denominator, we get -2 minus 7. So again, simplifying the top, we have a -6. Simplifying the denominator, we have a -9. And always reducing, we get 2/3. So right here, we can see that we have the same slopes. And anytime you have the same slope, that means your lines are parallel.
Just a reminder for teachers.
So continuing on, now we want to do the slope of EH. And again, if we plug that in, we're going to have a -4 minus 2. And our denominator, we have a -2 minus a -6. So simplifying on the top, we have a -6. On the bottom, we have 4. And when we reduce that, we get -3/2. So just by looking at these two, I can see that these are negative reciprocal slopes, and that's telling us that our lines are perpendicular. Now, HG and EH, if I take a look at the picture, I can see perpendicular would give us a right angle right there. Okay, so we want to do one more. We want to do FG, and if we do the slope of FG, plug it in, we have 8 minus 2, and on the bottom, our denominator is 3 minus 7. So again, we're going to have 6 on the numerator, -4 in the denominator, and that again, when simplified, gives us that -3/2. So again, if I look at EF and FG, again, we get those negative reciprocal slopes, and our lines are perpendicular. So all the way around, we're finding negative reciprocal slopes. And it's asking us to use those slopes to prove it's a rectangle. Well, we know perpendicular lines form right angles, and so we have just found a quadrilateral with 4 right angles. And this is giving us a rectangle. Okay, so now for part B, it's saying we're going to calculate the midpoints of the diagonals. So if we did the midpoint of EG, EG being one of our diagonals, midpoint, we're going to add up the 2 x values divided by 2, and then do the same with the y's. Add up our 2 y values and divide it by 2. So when we do that and simplify, I get 1/2, 2. So now our other diagonal that we're going to find the midpoint of is FH. So we're going to do the same thing. Add up the x's, divide it by 2, add up the y's, and divide it by 2. So simplifying this, I get 1/2, 2. So again, I'm seeing I have the same midpoints. If I have the same midpoints, this is going to show me that the diagonals bisect each other, and therefore proving it's a parallelogram. Now, if we take this a step further, we want to do the lengths of the diagonals. So if we do the lengths, we're going to start with e.g. length, just saying do the distance formula. So starting with e.g., I have -6 minus 7 squared plus 2 minus 2 squared. So step 1, simplify within the parentheses. We have a -13 that we will square. Over here we get 0. If I square a negative, remember it turns positive. So I get square root of 169, which when we reduce this, this is going to tell me the length of EG is going to be 13. So now we're going to do the same thing over here for FH. We're going to take the distance. So x2 minus x1, so minus a negative is plus a positive. And then we have y2 minus y1. So again, we're going to simplify the parentheses first. So 3 plus 2, we get 5 squared. Over here, if I simplify these parentheses, I'm going to have 12 squared. If we go back and square each of these, we get 25 and 144. And when we add that up, we get the square root of 169, which again is going to reduce down to 13. So what this is showing me here is my diagonals, they have the same length, and so that means they are congruent. So it's asking why, along with part B, where it shows that they bisect, why does that prove it's a rectangle? Well, properties of diagonals of a rectangle is that not only do the diagonals bisect, that's just a plain old property of a parallelogram that carries over. But then the more important property that separates a parallelogram from a rectangle is the fact that the diagonals are congruent. So once you have a parallelogram, which we did from this part, that also has diagonals that are congruent, which we found with the same lengths, we have now proven that it is a rectangle. And on the back, we're going to take a look at a rhombus. And our definition that we're going to stick with for a rhombus is a quadrilateral with 4 congruent sides. Okay, so we're going to use this information to prove that 2 triangles are congruent. So we're using that idea that I have a quadrilateral with all 4 sides being equal to help us prove 2 triangles. Any proof will always tell you we're going to start off with the given. So we're going to start off here just by saying that RSTU is a rhombus. And that's our given information. Now, knowing it's a rhombus and using our definition, we can say we have some sides that are congruent. So for instance, the ones that would help us here would be side RS and side TU. So if I mark those, we have those, and we can say, because we know that opposite sides, you could even say all sides of a rhombus are congruent. Now, property that we get from the fact that a rhombus is a parallelogram is we know the diagonals bisect each other. So we can say then RW has to be congruent to TW. And we also know then that UW has to be congruent to SW, because we know the diagonals of a rhombus bisect each other. And if we mark our pictures, I'm seeing 3 congruent statements. And as soon as you have 3 congruent statements, that gives you the pass to go and check your triangles, and sure enough, we can prove them congruent. That is enough information. So I can say triangle WS is congruent to triangle RWU, and our reason here is side, side, side. So this is just a basic idea to get us into proofs, idea with both coordinate proofs, 2-column proofs, and how we can use the properties of both a rhombus and a rectangle to help us solve some problems. We will do more with this in class and connect it more to coordinates and algebra as well.